Okay, kind of funny. I have realized that as soon as I start trying to record these labs, my dog, who's usually sitting in the chair over there, jumps out and walks out the door. I don't know what it is. She just doesn't like it. Anyway, let's go into Lambda functions and learn a bit about serverless security. Over the past 4 labs, we've built out the foundation of our automation platform by wiring together our centralized event bus and using a simple event bridge rule and simple notification service to validate that our pipeline works. This week, we'll set up our first Lambda function, which is where all of our application logic is going to live. Oh, never heard of Lambda functions? Never worked with them before? Well, this is where things get pretty awesome. It's time to talk about serverless. Now let's clean up some terminology to start. Everything I'm about to cover is more like development and operations, but you can't really secure things if you don't understand the fundamentals of them. Serverless is the term we use for cloud services you use where you don't manage the underlying servers. Well, think of it this way. With EC2, we ran an instance and we handled all the configuration of the software and the operating system. We're responsible for scaling, for sizing, overall management, patching, maintaining, updating. But Amazon S3, well, it's just this thing. It's a service, and we put files there. And what's cool is we can configure S3 to serve those files like a web server. And we don't have to install or manage any web server software, no Apache, no Nginx, or anything else. You just configure S3 to work as your web server. We don't have to deal with scaling. We don't have to deal with patching, updating. Now, do we know what's under the hood? No, we have no idea what's under the hood, and we never touch an operating system. So EC2 isn't what we would call serverless because we're still managing an operating system and handling all those nuts and bolts. But by my definition, which not everyone agrees with, I would call S3 serverless, especially if you configure to use it as a web server. It's a little confusing because some people, I mean a lot, tend to only use the term serverless when referring to something called function as a service, FAAS. What's FAS? It's a kind of workload, which is the term that we use to describe where code runs. So workload is where code runs. And it's easier to understand what FAS is if we list out the major workload types. To start, we've got physical servers, and if I need to explain that to you, like go back a few years, learn your alphabet, how 2 + 2 = 4, and then come on back. Then we have virtual machines. With virtual machines, we run our code or applications within a full operating system, a VM that's running on a hypervisor. And an EC2 instance is just a kind of a virtual machine. Then things get a little bit different, and this is the new-ish stuff. One is containers. With containers, you encapsulate an application and its dependency into the container, which is this software construct. And containers themselves, like you'll have multiple containers running on top of a virtual machine or a physical host or multiple hosts, and we call that a cluster. And then that means that the containers are running on top of and within a regular operating system in the little isolated bubble that the container software builds. Some containers are really heavy, and we do use them practically like virtual machines. And others are really lightweight, and that's kind of how it should be, where they just do a job and they shut themselves down. Containers are isolated, but not as strongly as virtual machines, because a container relies on the operating system for isolation, where virtual machines can actually use special hardware. Modern hypervisors have all sorts of special hooks and hardware, and this is built in all the servers, including the ones that are the computer that you're watching this on right now. And that has a lot of performance and isolation capabilities. So containers, they'll share operating system resources, where virtual machines, even though they're sharing the hardware, there's hardware things to make sure that's still isolated. All right, what about serverless functions, function as a service? Well, you load up and run your code in the cloud provider, and you don't deal with the underlying operating system, you don't deal with the container. This is because your code is triggered, runs, and shuts down. It really is like a function. You're not running like a persistent, long-running application. Now, function as a service functions typically run in a container, and in a cloud provider, that means they're running on top of a virtual machine. But these aren't times to be making Russian doll references. And yeah, okay, got political there. That's really a key difference between function as a service and other type of workloads. The code you load runs when triggered not all the time when you're using serverless functions. When Lambda, which is Amazon's serverless functions, function as a service, and it was the first one that I think in the market, it would time out originally, I think in like 30 seconds, might have been even 10 seconds. I can't remember back that far. And it really is expensive to run it for more than a few seconds, even though they've pushed that out to you can run them for minutes now. Lambda is what we use to build event-driven applications. The function is triggered, it gets passed in some data, and it does something really fast, and then it sends out its results, and then it resets itself for the next request. Here's where it gets really cool. You don't have to worry about scaling or performance. I mean, you do once you get big enough, but stick with me for now. If I send in one event on my event bus, it triggers one Lambda. If I send in 10,000 events at the same time, 10,000 Lambdas run in parallel. I pay for the invocations, but I don't pay for anything if the Lambda is just sitting there and not actually running. Okay, I'm not going to get into cold starts and warm starts. Those of you who actually know this stuff, we'll get there eventually. Lambda functions are really ideal for the kind of application we're building. It's lightweight, and I never need to worry about a server or a container. I don't need to patch or update anything other than my own code. It doesn't cost me anything when there aren't events, and for many architectures, it's really super cost effective. Yeah, you can support complex application logic using multiple Lambdas and event buses, message queues, and other components. These designs scale really well, and if you're going to build a startup thingy, I would always try to go event-driven and serverless as much as possible. Okay, so let's talk a little bit about serverless security. To do that, we have to start by talking about how a Lambda function works, and then I'm going to go into the main security principles. Only going to take us a minute or so to get through this. When you create a function, you create the function, you provide your application code and some configuration options, and you're going to see a bunch of those in the lab. Your function is assigned an IAM role, and all functions need a role so that they can do anything, and you want to set that IAM role to least privilege. Then you trigger the function from the outside. This can be from an event bridge rule, an SNS notification, a simple queue service message. You can directly invoke it from a URL, from a load balancer, API gateway, or more. That's the collection of things that you can trigger a Lambda function on. When you trigger the function, you pass in some information, an event, or the data you want it to process. At that point, the function runs. It just runs the code, uses the role you assigned, and you can add in things like environment variables, you can connect it to a VPC, and there's a lot more advanced things that these Lambda functions can do. Now, if you don't put it on a VPC, by default, Lambda functions in AWS can access the internet using Amazon's network. We are going to talk about this in future labs and when to connect it to a network or not connect it to a network. And then the function will send its output to wherever you tell it to, you write it into your code. By default, functions are going to log into CloudWatch logs, and we're actually going to see that as part of our lab today. And when everything is all finished, when that code is done running, the function just turns itself off. It's done. It runs the code, and then it exits. Depending on how things set up and what's going on at the time, the entire runtime environment itself may also tear itself down. All right, so let's go ahead and look at an image, and I want to talk a bit about the security. So I just want to cover a few key principles around Lambda functions. The first is this diagram shows here how you have the Lambda function. Oops, let me change. I had my eraser on, and I want to go to my pencil here. Got it. Okay. So we have the Lambda function here, and then that Lambda function in AWS, it does run inside of a container, and that container runs on top of an instance. And there's actually been a fair bit of research around this that actually shows you can trace that back. Some people have even done things to actually pull data from the instance. Amazon's got really good security around this, but there are some things that a little bit of research you can kind of get exposed to. Okay, so I have my code. I write my code, and I load that up into the Lambda function. That's just sitting in AWS. Now, the next thing that happens is that needs to be triggered. And so the triggers can things like SNS or event bridge, as we talked about before. So when that trigger hits, and remember, I can have 1 to n. I can't remember the default limit, what we call concurrency. I think it's like 10,000. I mean, it's some really big number that you can run simultaneously. That Lambda function will stand up and it will go ahead and run. Now, from a security perspective, that means that there's, I call these kind of my, Rich's 5 serverless security principles or something like that. Go read the blog post. I can't remember what I wrote in there. So one is your code itself, you don't want insecure code. You can still have buffer overflows and other kinds of things. Maybe it's harder to execute on those, but there have been some research to show that that is absolutely possible. So you want to run all your standard security tools like static analysis and software composition analysis. Now, we're not going to do that in these labs. That's really kind of bigger, more enterprising environments and CI/CD pipelines. And, maybe we'll get there eventually because I actually do have training materials and all that stuff. But having secure code is one. The next is, and really one of the most important ones, is that IAM role. And you want to make sure that that IAM role is a least privilege role and that you don't overprivilege it. I have done multiple assessments where I've come in and I've seen it have full admin privileges to that IAM role. And in some cases where anything could trigger it and where the code had insecurities in it. I mean, that's like the trifecta of the bad stuff that can happen here. Okay, so that's the first main things here is making sure your code is secure and then making sure you're following least privilege. Those are the two most important ones. But let's talk about a few of the others. The next is what can trigger it. In particular, if your code does anything sensitive, you don't want anything that is unauthenticated to trigger the code. Remember, so this is auth-n, that's your authentication of what can trigger it. And then your role itself is the auth Z, which is what can it do. So really important to make sure you've got that authentication in place. Again, I've seen these like behind a load balancer. The last one I hit was behind an application gateway. It was unauthenticated. It had an admin role, and the code was like a little wonky. You could do you could get information out of it that you wouldn't want somebody to go ahead and see. Now, there's a couple of other ones that we do need to talk about. Lots of times we have secrets. And so secrets, like if I'm giving access to some kind of a database or something else, you do not want to put your secrets into environment variables. We're not going to use those today, but if you play around, you look in the console, you can see you can provide environment variables to the Lambda functions. Or if you do provide those, you provide it just at runtime because those are going to be exposed because that's visible inside of the console. So you want to be very good about and making sure you're smart about your security around your environment variables. See, sometimes I don't look at the screen as I'm writing, so I said secrets there. And then the next thing is you want to make sure you're good at your logs, and that's part of what we're going to do today. I'm actually going to show you how to do a log framework. Now, there's one piece that I don't have on in here, which is the network security, so I'm going to call it just NetSec, and that is putting it onto a VPC. And basically, by default, that Lambda function can go out and access the internet. If I put it on a VPC, then I've got more security that I can apply to that Lambda function. And that's beyond the scope of what we are going to get to in the lab today, but we will talk about using that in future labs. All right, so let me go ahead and put that iPad down. That's really most of it. Our application is relatively simple. So we won't need to deal with any of the secrets management, and we don't need to deal with the environment variables, network access. But you will see the triggers, you will see the logging, and you will see the use of least privilege IAM roles all in the lab that we're doing today. And I don't know, I think our code's probably secure. I'm not going to run that through any testing tools. All right, let's jump into the lab. For the lab today, what we're going to do is create our Lambda function, and we're going to wire everything together so that we will actually change the tag on the S3 bucket, and we'll see that recorded to a log over in CloudWatch Logs. It goes quickly, but there is a lot of steps in different parts of the console today, and I'm going to try and go through methodically. It took me about an hour-ish to go ahead and figure out how to get everything in the right order here, so hopefully it'll work well for the lab. So with that, the first thing we're going to need to do is we're going to create our IAM role first. Then we're going to add some permissions to our event bridge rule so that that can work. And that's before we even get into building the function itself. Now, the reason for this is, well, you know what? Let's just jump in and do it because it'll make more sense. All right. Going into your sign-in console, we're going to create our function, and this is going to be where all of our auto remediation logic lives. And to start, we're going to go ahead and go in with admin access, and we're going to go over to IAM. Now, our Lambda function is going to need a role, and Lambda itself can create its own role in the console. It'll kind of do that by default, but that gives it minimal permissions. And we need permissions to do some stuff in S3 because the way I'm going to set this up is as our read only for now, and then we're going to add our read write permissions a little bit as we go along into the next labs. So to do that, we're going to create the role ahead of time because it needs more than what the console would build for us automatically, and then we pick that role. So going into roles, and let me pause and flip over to get my naming conventions. Okay, we'll create the role. And then we want to pick AWS service, and we'll use Lambda. It always comes up. EC2 and Lambda are the two most common reasons for these. And yep, we're all set with Lambda. What that does is that just predefines the trust policy for us, so it saves us a little time. Next. We're not going to add a policy yet because I can't just go ahead and manage that from here. You'll see why in a minute. And let's go next. And we're going to give it a role name. So the name that I put into my notes to use is Lambda S.L.A.W S3. So you know it's for Cloud S.L.A.W. You know it's a Lambda role. I don't really care the order of the conventions here. That works for me. And I'm going to leave the description off this one. That name is pretty good. Now, I need to select trusted entities, and we already have it set for Lambda. I could actually restrict this to just the Lambda function that I need to use, and you'll see we're not really going to do that at this time. So any Lambda function can technically use this role. Not necessarily ideal, but for the lab purposes, it kind of just saves us a couple of steps here. Now, once I create it, I need to actually go ahead and add the policy. I didn't add any permissions because I don't want to use a managed policy. Now we're on the permissions page, and we need to go ahead and add permissions, and we're going to go ahead and create an inline policy because we're only going to use this here. We're not going to use this anyplace else. It's just very specific for this function that we're using. I'll go to JSON, and let me go pull it from the blog post. All right, I copied it out of the blog post. Let me paste it in, and then I'm going to need to replace my account ID in 2 spots. And you see you've got the red arrows there to do that. So pretty easy. Just go into your upper right-hand corner, copy the account ID. And there's a couple of places where we have this. So remember, get rid of those carets. We're going to go here, paste it in, and the error goes away. So this is going to allow us to create a log group for logging. What we're doing is this is least privilege. It's only allowed to create logs for this actual function that we're going to use it with, even though we haven't created the function yet. And then we'll go paste it there. Now, you'll see that I'm cheated a little bit. This security auto S3, let me see if I can zoom in there. That's going to be the name of my function, even though I haven't created it yet. I've just gone ahead and planned for this and hard coded that in. So this is only going to be able to put a log stream and put log events to a stream associated with that specific Lambda function. The asterisk at the end here is because it's going to do a different like little log stream for every function that's running. And so that's the way that you can actually kind of correlate and track things. Our actual permissions for what we want to do, this is a bunch of the read actions we need for S3, and we're going to be using those as we actually start building out the analysis part. And then later, you're going to see we're going to add permissions to actually make the changes to things, to do the auto remediations. All right, we'll click next, and we're going to call it, I don't know, Lambda S3 for now. And then I'm going to click create policy. And you can see that that is directed directly there as an inline policy. The next thing we're going to do is create our actual Lambda function. So let's go to Lambda. And look, you could even do like little play functions right here, but we're going to go straight to create a function. Now we have to have the correct name, and I'm going to pause, pull it from the blog post because I don't actually remember it, even though we just use it in the policy. All right, so I've copied that out, and make sure you use the same name for your basic function. Now here's some important things that we do need to set. So the runtime we're going to use is Python. I do all my coding in Python. Next, we're going to go with ARM64. That's actually cheaper and performs better. It doesn't really make much of a difference for this lab, but just unless you have a reason to use x86, I've started switching everything over to ARM64. Now, we do not want the default execution rule. So let's click that down arrow. And then we're going to click use an existing role. And it'll pop up the only one that has permissions for Lambda. It's like they do cool stuff in the console these days. I actually want to give them credit. Now, we're not going to change any of the additional configurations, VPCs, taggings, function URLs, any of those things are beyond the scope today. So pick your role and then create the function. Now, this function isn't doing anything and doesn't have any code or anything yet. So, shouldn't be a deployed version, but you probably don't see this. I'm just going to go ahead and ignore it. That might have been because of my testing in my environment. It found a version with the same name that was left over. I did delete all of that out before doing this. So you can see here the function overview. What is the trigger? What is the destination? Right now, we just have the function, and we basically have nothing code. This is, though, a couple of key pieces to understand here. So import JSON, because we do everything with JSON and the events are kind of always passed in as JSON. Then this is the handler event. So you can have all sorts of code and everything else. This is what is configured on the outside. Let me actually show you. Come on, zoom out. All right, let me move my mouse over here to zoom out. There we go. So this is all like the parts of our Lambda function, and these can end up being pretty big. But one of my configuration options is what gets called. And so as part of, well, that's not in there, but you can actually tell it what handler to call. Anyway, this is just the default. What we're going to do is we're going to modify our code. I'm going to explain a little bit more of this as we go along. Let me pause because I'm going to copy and paste the code out of the blog post. So now I want you to do the same thing. So copy and then paste. Apparently I didn't copy. Give me 1 sec. All right, let's see if it worked this time, and paste. Okay, so here's all the code, and I'm going to explain what we have here. The first thing is I mentioned we are going to pull in some logging functions, and we're just using a basic Python logger, which is the default. It's a little bit better. Any print statements will actually go to the log, but we have this set up just to do regular old, use actual like more professional level logging. Next is the Lambda handler itself. So it's going to get the event and the context. Those are the two things that are sent in by the trigger. When you trigger, the event is you passing in the data and the context. Ignore the comments here. You can tell I used a little Anthropic Claude to help me write this with a little customization of it. Then we have our error handling, so try, accept, fail. And the main thing is all this does is this takes the event, received event, and it logs it. And then it takes the context information, and then it logs the context information. And then that's pretty much it. It says that the event was successfully logged, and then it goes ahead and turns itself off. And then any exceptions get logged. That's all we're doing. Whatever we get passed into this will get logged into our CloudWatch logs, and that was the permissions that we set up that this function has. All right. So there's not a save, there is deploy. So we're going to go ahead and deploy this. Why is it deploy and not save? Because you are literally deploying this. This is now functional, potentially running code in your environment. And again, I said we're going to skip all of the rest of a lot of the rest of this stuff. The one thing is I'm going to pause while I look for it just because I would like to show you. And then over in configurations, here's where if you wanted to set a VPC, you could drop this onto a VPC, and then you have security groups and all of that. You could do some code signing stuff. There's a lot of really cool things that you can do here, as well as environment variables. But remember, those we're not playing with right now, and you don't want to put secrets into environment variables. You could actually connect everything up to Amazon Secrets Manager, and then that would dynamically, based on the IAM role, only be able to pull the secrets that this function has. It's pretty cool and reduces the exposure of those secrets. But we're doing really simple. All we're doing is logging. All right. You'll notice we don't have any triggers here. Well, we're not going to add our trigger here because if I actually try and do this and event bridge, it doesn't show my rules. And that's because we're off of our default event bus. That appears to be a limitation of the console. I'm actually going to check with my friends over at AWS. Maybe we could get that dealt with. So instead, we're going to go to event bridge because that's our trigger. An event bridge to get to the rules. Okay. And then we'll go to rules. And then the rule, remember, we have to switch to our security automation event bus, and there's our rule. I click on the rule. And you'll notice this doesn't need any permissions to do this stuff. It's going to explain why in a minute, because I'm going to go to targets. And right now we have it sending to SNS. That's what we configure. We are going to leave that. And we're going to leave that so that we have a little bit of redundancy in our testing, but I would remove that before I go into production. We're going to hit edit. And now we're going to add another target. So that means this rule is going to actually simultaneously go with both targets. And the service, we'll go here, we'll pick Lambda, EFGHIJKL, Lambda function. The Lambda function is in this account, makes it easy. And we only have one Lambda function, makes it easy. And we're going to say create a new role for this specific resource. This is a role that is going to allow EventBridge to invoke, and that's the term we use to trigger, to invoke our specific Lambda function. That is the default that this creates. So this saves us a little bit of time, and this is a pretty good way to do it in the console because it is defaulting to least privilege. Let's click next. Without that, my Lambda function or my EventBridge rule cannot actually trigger the Lambda function. It has to have permissions to trigger the Lambda function, and you can see that it has the role there. We don't need that for SNS in the same way. That's just because of how the different services work, but we absolutely want to be restrictive on triggering our Lambda function. Let's go ahead and click Update Rule. So now our rule is set, and if we look at targets, you'll see I have my security testing and my security auto S3. Now, unfortunately, and you'll see this as we go into the Lambda function itself, go back to Lambda, click on my function. It doesn't actually show the trigger here. And I'm not sure the exact reasons it doesn't pull up in the console. Just understand that this is all wired correctly. Okay, how do we actually test it? Well, we have a function that is triggered by our previous EventBridge rule that we have already tested. And in this function is code that's going to just log that event into CloudWatch logs. Let's go ahead and close this. And we're going to go into our Cloud.SL.A.W account and administrator access. Now, if you are on the same browser that you used the previous week, if you click in that upper corner, you'll probably see your role history with the ability to switch the role over to your, what did we call it? Your production 1 account. And that's what I have here for the video purposes. I'm going to use this. Otherwise, you go into organizations, you pull the account ID, and you can follow the instructions. And again, pull from the blog post because I'll repeat those instructions in the blog post. But for video purposes, I'm just going to click on this because it's in my role history. And I don't have to do the whole like switch role thing manually. Then I'm going to go to S3. And I have my one bucket. Click on that bucket. Properties. I'm going to edit my tags. Add a tag. And it's just going to be whatever junk I feel like banging on my keyboard. Save changes. That's it. That's all I need to do in this account is add that tag. Let's close the window. And then we're going to just jump back to security operations. Now, you probably, if you want to check to make sure things are working, check your email and you would have the email notification we got. But in this case, we're going to look and make sure it's logged. And so CloudWatch. And then I'm going to go into my log groups. If everything worked properly, I'll have a log group here. Oh yeah. If you don't have this, that means permissions were set wrong or your Lambda function didn't trigger. Join Cloud.SL.A.W Pro and I will go ahead and actually try and help you debug it. But if you follow the instructions, everything should work just like it did for me. Okay, so I have this log group. This was created because remember, we gave the Lambda function permissions to create a log group and name it after itself. And if I go in there, you'll see that I have the log stream. And if I click on that log stream, this is what that one function did. And so you see some default, it's started, and it's the runtime information and other things, start request. And then we start getting into the meat and boom, look at this. We said log it with a level of info and log. That's the API call we made to change the tag. And it pulled all of that event information in right out of CloudTrail. And then there's some other stuff. So I think did we log the context next? Or did we log that before? Remaining time. I can't even remember. And then the end time of it. So this is great. Everything worked. We created our Lambda function. We started by creating a role to give it permissions to read into S3. Now, are we reading S3 today? No, we're going to do that in the next lab, but this gets us started. Then we created the function itself. Then we created the trigger, and we did that over on the event bridge side because for whatever reason, we couldn't do that within the Lambda function. That's a limitation of the console. If we're actually doing everything with API or with CloudFormation or with Cloud Development Kit, those things, that wouldn't be a problem. Then we got it all wired up and we tested it. So let's think back to what we have in our big. You know what? I'm going to pull this up real quick. I'm going to switch over to the diagramming, the whiteboard. These are all the ones that we've done. And I'll show you where we are today. If we go back to our evaluations and actions, we have our triggers set. We haven't done the time base. And actually, that's the wrong one. We've got here our security operations. We pushed everything out. We have our rule triggers. Instead of sending an SNS, it's actually now triggering a Lambda function. And that Lambda function takes the event and logs it. Now, I know it's wired correctly. Now, why do I need that event? Because that event has the information I need to do the analysis. We're going to be building the analysis out, and we're going to be building the auto remediations out a little more slowly. I know it seems like a bit of a drag, but we do have to talk through how to actually start writing that code. So that's where we're going to be next. But right now, we've got all the fundamentals wired up. Make a change, passes the event through, triggers my Lambda function, saves my log files. It's cool stuff. And I hope you have a great week.